Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to learn about the important concept, that is refractive index, and also some of the important subtopics under this, that is absolute refractive index, relative refractive index, optical density, then the speed of light in different medium. So all these concepts we are going to learn in this video. Students, if you are new to our channel, subscribe our channel and also share this video with your friends. So if you are preparing for board examination, these videos will be very helpful for your board examinations. So don't forget to subscribe our channel. So let us start the video now. Let us see what is refractive index. So refractive index is represented by small n. So small n means it is refractive index. So let us take one example to understand this. So now let me take two different mediums. So here I'll take, this is air medium and this, let it be medium 1. And then I'll take water, let this be medium 2. So I have taken two different medium. So now light will pass from one medium to another. So it is passing like this from one medium, and when it enters into another medium, you can see it will bend like this. So instead of passing straight, it will bend like this. So why it is bending? What is the reason? The reason is because the speed of the light will decrease in the second medium. Here the speed of light was high in medium 1. When it is entering into medium 2, the speed will reduce. So there are two different speed now. So comparison of this speed is called as refractive index. So how do we write here is, so here write small n. So small n meaning it is refractive index. So where refraction is taking place, whether it is taking place in medium 1 or medium 2, you can see bending is taking place, that is refraction is taking place in medium 2. So therefore you have to write 2 with respect to medium 1 is equal to. So here refraction is taking place in this medium. Then the other medium we call it as reference medium. So now this is called as reference medium. So I'll write here, this will be the reference medium. Reference medium. So in this case, air is the reference medium. So I'll write, always in the numerator we have to write reference medium. So speed of light in air divided by speed of light in water. So this is the refractive index. Refractive index meaning is comparison of speed of light in two different medium. So the reference medium should be in the numerator, and where refraction is taking place, that medium should be in the denominator. So let us take one more example to make the concept clear. So let me take one more example. So here let us take water as medium 1 and glass as medium 2. So now pass the light. So this is the ray which is entering from one medium. When it is entering into another medium, you can see it starts bending like this. So now where refraction is taking place? Refraction is taking place in the glass medium. Then the other medium should be taken as reference medium. So here we will be taking water as the reference medium. So this is the reference medium. So now how to write the equation? So you will write refractive index, where the refraction is taking place, that you have to write first. So refraction is taking place in the glass medium. So you will write 2, medium 2 with respect to 1 is equal to. So write reference medium in the numerator. So you will write speed of light in water divided by speed of light in glass. So is that clear now? So where refraction is taking place, that you will write in the denominator. The reference medium you should write in the numerator. So this is how we write the refractive index. So now coming to the first concept, which is absolute refractive index. In absolute refractive index, always in the numerator we have to take air or vacuum. So this is fixed. The reference one is fixed. It should be air or vacuum. So I'll write here it should be air or it should be vacuum. And the other medium, second medium, can be anything. Then this is called as absolute refractive index. So here you will be writing the equation like this. Absolute refractive index of the medium is equal to speed of light in air or vacuum. You will be representing it as C, divided by speed of light in water or any medium. So it can be water or it can be any medium. So we will be writing the speed of light in this medium as V. So this is the equation which is very important. We will be using in calculation. And C value, we know that speed of light in air or vacuum will be equal to 3 into 10 to the power of 8 meter per second. So now this is called as absolute refractive index. So here I'll write this is called as absolute refractive index. So what is absolute refractive index? When you are comparing the speed of light in air or vacuum with that of any other medium. And second is called as relative refractive index. So in relative refractive index, you are comparing any two medium. So here you are comparing water with glass, or you can compare glass with diamond. Any two medium you can compare. So this is called as relative refractive index. So this is relative refractive index. So is that clear? So now we are going for the third concept, which is called as optical density. So optical density meaning is in that medium, if the optical density value is more, the speed of the light will reduce in that. So how we relate is, first equation, refractive index is directly proportional to optical density. Second relation is refractive index is inversely proportional to speed of light in that medium. Speed of light. So these two are very important. We are going to use to find the speed of light and also the optical density of the medium. So these two equations are very important. Meaning here is, if refractive index value is more, then optical density of that medium also will be high. If refractive index is more, then the speed of light will be less. So this is the relation we are going to use. So one example we will take. So here we have taken two different medium, water and benzene. So for water, refractive index is given as 1.33. For benzene, refractive index is given as 1.50. So the question here is, find where optical density will be high. Second question is, find where the speed of the light will be high. So now to find the optical density, where optical density will be high. So see here what we have written. If refractive index is greater, optical density also will be high. So which is bigger value here? 1.50 and 1.33. Which is big here? The bigger value is 1.50. So here refractive index is more. Therefore optical density also will be more. So in benzene, optical density will be high. So I'll write here benzene. So second is, where the speed of the light will be greater. So you can see here, if speed of light will be greater when the refractive index is less. They are inversely proportional to each other. When one increases, the other will decrease. If the speed is increasing, then refractive index will decrease. So it should be less value. If it is lesser value, then the speed will be high. So find where the value is less. The value is less here, 1.33 water. So in water, the speed of light will be high. So here I'll write water. So in water medium, the speed of the light will be high. So let us take one more example. So two mediums we have taken, rock salt and ruby. So in rock salt, refractive index is given as 1.54. In ruby, it is given as 1.71. So again, first question is, the optical density is high. In which medium it will be high? So if refractive index value is more, then optical density also will be high. So see where the value is bigger. So bigger value you can see here, 1.71. Therefore here optical density will be high. So here I'll write, in ruby optical density will be high. Second question is speed. Where the speed will be high? Speed will be high when refractive index value is less. So where it is less? So here it is less. Therefore in rock salt you can see the speed of light will be high. So I'll write here rock salt. So this is how we find out the speed of light as well as optical density. So if you want to compare, so here I have taken two medium. So like this you can take 3, 4, 5 mediums and you can compare by keeping the refractive index value. You can easily find out which is having more optical density, which is having less optical density. Same way where the speed is high and where the speed is low. One more example, we are taking again two medium, water and diamond. So for water, the refractive index is 1.33 and for diamond you can see it is 2.42. So the question here is again where the optical density will be higher. Compare this two medium, and then speed where it will be high. So compare this medium and find out. So students, I want you to find the answer and write in the comment section. So find where it will be high, where optical density is higher and where speed is higher. So if you have any other doubts, you can write in the comment section. So I'll meet you in the next video, students. So don't forget to subscribe our channel and also share this video with your friends.